Do-do-do-do! Breaking news! Last night, major crime occurred in nearby local Capitol Hill district near downtown Denver. Stay tuned for details to follow. Do-do-do-do! While spending a pleasant evening in listening to his newly downloaded police scanner app, notorious vigilante and local math teacher, #Mr. D, decided to set out and solve this terrible, horrifying, horrendous crime on his own, using the only way he knows how. Math. Attention, all units be advised. Vehicle reported to have fled the scene of the crime has been spotted on the southeast corner of 13th and Ogden. All units be advised.
Oh, hey there, gang. How you doing? Do me a favor and help me solve this crime, would you? You only need a few simple things. A pencil, paper, your calculators, and your minds. Go ahead and take those out now. At around 10:15 p.m., a witness called to report this car speeding from the scene of the crime, where a bundle of TI-84 Plus Silver Edition calculators were stolen from Mr. D's secret collection. Here we are now at the suspect's vehicle, and let me share with you a few of the things that we know so far. Be sure to take good notes. Again, the crime was reported to have happened at 10:15 p.m. It's 11 o'clock now, 45 minutes later, and the engine is still warm. Our suspect swears to have spent the evening at a friend's house. He says he returned home around 10 p.m., went inside, and talked on the phone for a while, until about 10:20. The friend on the phone confirms his alibi. When I say go, pair up into partners or groups of 2 to 3 people each. With your groups, make a list of all of the information that you have so far. Write down as many things as you can. Rewind the video if you need to. As an investigator on this case, do you have enough information to prove this suspect guilty so far? If not, what kind of things are you still looking for? What information? What data might be important to you? Write down any questions that you might have. Consider making a list of these are all the things that I do know, and these are all the things that I'm looking for.
While police have been inside investigating and questioning the suspect, I've been in here doing a little bit of research on my own. Let me fill you in on what I found. In physics, there's this sweet formula discovered by Isaac Newton called Newton's law of cooling. Here's how it works. Imagine you're an investigator or forensic analyst, and you walk into a crime scene where you find a dead body. Immediately you note the temperature of the room that surrounds you. It's about 70 degrees or so. Bodies reside at a temperature of 98.6 degrees, and because the body is dead now, it's not able to heat or cool itself anymore. So slowly, in an exponentially decaying function, the body temperature is going to decrease to the temperature of the room that surrounds it. Now, if you're able to know three certain constants, 1, the temperature of the room or the environment, 2, the initial temperature of the body, and 3, the temperature of the body now, then you're able to plug these into Newton's law of cooling formula, and it'll tell you how long the body's been dead for. Here's Newton's law of cooling. It looks intimidating at first, but let's talk about what each one of these variables means. Make sure to write this down now. This big T at the beginning represents temperature after time has passed. What that means is if I plug in some amount of time, say 30 minutes, it tells me what the temperature will be that much later. The A in this equation represents the temperature outside, or the temperature of the surrounding environment. T naught, or T with that little zero, that represents the initial starting temperature. That's like asking yourself, what was the temperature at the very beginning, when time equaled 0? That little k, that's what we call the decay constant. We're going to solve for that here in just a minute. That T in the exponent, that represents how much time has passed. How much time has passed between T naught, your initial temperature reading, and that final T that you're solving for at the end. This equation's got a lot of stuff going on with it, but I've already gone ahead and done the first hard part for you, and that's rearranging to solve for K, your decay constant. Let me share some of this new information we have with you. When I arrived on the scene of the crime at exactly 11 p.m., the temperature of the engine was 150 degrees. It's been 10 minutes now, 11:10, and the temperature is 130 degrees. The outside temperature is 70. See if you can use this information to figure out what your decay constant is. Make sure you take your time when you're plugging these values in your calculator and pay attention to the order of operations. Make sure to check with Miss Wolf that you have the right value in the end. Were you successful in finding what the decay constant of the temperature of the engine was with your partner? Let's talk a little bit about what this means. So say that I walk into a classroom with a cup of coffee. The classroom is about 70 degrees Fahrenheit, and I had just heated my cup of coffee up, so it's about 140 degrees. Now, slowly as time goes on, the temperature of my cup of coffee is going to slowly approach the temperature of the classroom. It's never going to get colder than the classroom was, because that's not possible. That's what we call an asymptote in this exponential decay function. So, what's that mean in terms of the car's engine? Well, when the car was turned off, the engine was at a certain running temperature. And over time, the temperature of the engine is going to approach what the temperature of the outside air is, 70 degrees. So, detectives, here's your last bit of information. Recall that the suspect swore that he arrived back at his house at 10 p.m. He would have gotten home, turned off the car, but his engine would have been in its running rate temperature, a temperature of 200 degrees Fahrenheit, at time t equals 0. Now, using the equation and our new value for our decay constant, plug these in and see if you can figure out what the temperature should be at 11 p.m., if everything he says is true. Compare that to the value that we found that we actually measured when we got there. What was the temperature at 11 p.m.? Have we found enough information yet to prove whether or not the suspect is guilty?